Assalamualaikum. Today we are going to present our project for data structure and algorithm. So our project title is Student Image UI using linked list. First thing first, I would like to introduce myself as a team members, Muhammad ZUHILMI Ammaar, and my friend Muhammad Ammar. The first question is application title and description. So this we choosing linked list application. Um, it entitled student email GUI. For the description, this project about a student GUI that stores student objects in the linked list, and although it allows the user to add student, delete student, display all students, and exit. For the second question, explain how the application works. So we're choosing two operations in linked list, which is first is insertion, which is to add a student email at the given position. And the second operation we're choosing deletion, which is to delete a student email in the project. So this project is a Java class named student email that has data members for the name and the number of student. The class have a constructor and appropriate accessor and also mutator methods. In addition, the toString method include the output information with student names, student numbers, and the corresponding email address. The email address is a string with the student numbers, and the end of the email, which is for example such as @my.email. So this is also a program that creates a GUI with two labels of text field, each one for names and student number, a text area to display the information, and the buttons in GUI. So for the first operation, which is add, when the user enters the data into the text field and click the add button, a student email object is created and stored in a linked list. And then the student names, number, and email is displayed on the text area. For example, of insertion operation, we adding a new node in linked list is more than one step activity. We shall learn this in this diagram here. So first, I create a node using the same structure and find the location where it has to be inserted. So we have three nodes here. For example, this is node A and this is node B. So imagine that we are inserting a node B between the node A and C, and then point B next to the C. And then it should look like this. And now the next node at the left should point to the new nodes. So this will put new nodes into the middle of the two. The new list should look like this. So similar step should be taken if the node is being inserted at the beginning of the list, while inserting nodes at the ends. The second last node of the list should point to the new nodes, and the new nodes will point to the null. For the second operation, we're using a delete operation. So basically in this project, if you want to delete a student email entry, you can enter the student name in the text field and press the delete button. If the enter student name doesn't match any name in the linked list, a dialog message box will pop up to indicate this. So, for example, deletion operation is also more than one step process. We shall learn this with this picture representation. First, locate the target node to be removed by searching by using searching algorithm. So we have three nodes here. So the left are the previous node of the target now should point to the nodes uh, to the next nodes of the target. So this will remove the link that was pointing at the pointing to the next to the target node. Now using the following code here, we will remove the target node is pointing at. So we need to use the deleted node. We can keep that in the memory, otherwise we can simply deallocate memory and wipe off the target nodes completely. Number three, pick any one operation and present the algorithm. So find the running time and estimate the efficiency of the algorithm. So when accessing elements of a linked list, speed is proportional to the size of the list with bit O notation. So when inserting a new node into the beginning of the list, it only involves creating a new node with an address that points to the old head. So the time taken it will take to perform this not dependent on the size of the list. This means that it will be constant time or a big O in bracket 1. So inserting an element to the end of the list involves traversing the whole list. And then creating a new node and adjusting the previous node address for the next node. Time taken will be proportional to the size of the list and big O notation. When we are inserting a new node into a position between or in the middle, um, and end of the link of the linked list, we will have traverse the list up until the specific point, and then adjust the pointer with the big O notation. At the same time, complexity is also true for removing nodes from a linked list. To conclude this finding, first, when we assessing element of a linked list, speed is proportional to the size of the list with a big O notation. And second is we must traverse the entire list in order to get to the desired elements. It's more costly compared to accessing element of an array. And the last one is a linked list consists of multiple blocks of memory at different addresses. This means that the size is variable because the elements are allocated memory at runtime. Question number 4, Ammar Safirwal will present this.
Okay. Assalamualaikum. About question number 4. Number 4 is present the existing application code with the output. Identify the collection class and the interface use list of the operation for each. Okay. for this GUI, we are using a public class student email GUI extend JFrame. Okay, as we can see at the coding, we can see the GUI component, and we can see that class instance data. Next. Okay. The next, we are using a public student email GUI, and then as we can see the flow panel, we are using the ID text field, name label, and text field. This is a flow panel, and for the next, we are using a grid panel, edit save button, and then student text area we can add, and add button addition listener for the event for the add student, as we can see at the coding. Okay, for the next one, this is a private boolean, is a student linked list, and we are using a private void add student. This is my labels set text error thought string. The J option pane show messaging dialog. Next. Okay, for the private void, we are using private void to delete student too, and we can add and delete. So in this coding, we can delete for student. Yeah, it seems like before slide before this, but we are using this is for delete student. Okay, and lastly, it can display all the student. Okay, for the display all, private void display all, we are using private, and at the top we are using private void for display all, and the second we are using private too for exit application, and lastly we are using public void main to show all the student, as we can see. Okay, for the public class student email exception, for extend exception, we are using public class student email exception to extend exception, as we can see the public student email exception and everything. Okay, for public class student email, we are using public 2 and public final string to show the email student, and public student email string we show that name, string ID, and everything from the email. And we can remove a leading and trailing space tabs, and J option pane show messaging dialog. It's a null error name, cannot be blank. For the next, we are using J option pane show message dialog. It will show the ID cannot be blank too. And lastly, if everything is okay, it will show the message is okay, set class, and then the value will add. Okay, for public class student email, we're using public string name and public string ID and everything, and it will combine the ID name and ID name and the email to set the email and everything. And for this, we are using public class too. For the output, as we can see at the slide, we can see the ID, the name, and the email. And we can test data, add data, edit, delete, and display all. Okay, for the conclusion, linked lists are the data structure that are used to store data item in a linear fashion but non-contiguous location. A linked list is a collection of nodes that contain a data part and a pointer that contain the memory address of the next element in the list. The second point is the last element in the list has its next pointer set to null, thereby indicating the end of the list. The first element of the list is called the head. The linked list support various operations like insertion, deletion, traversal, and etc. In case of dynamic memory allocation, linked lists are preferred by over array. Linked lists are, for the last point, is linked lists are expensive as far as their traversal is concerned, since we cannot randomly access the element like array. However, insertion deletion operation are less expensive when compared to array. So that's all from we. Thank you.